Okay students, so this is page 103 and this is example 9.2. This is an example to help us illustrate how to do a hypothesis test for the difference of means when sigma 1 and sigma 2 are known. A tip-off, if they're known, is a lot of times they'll give them to you as sigma 1, sigma 2. So here we've got camp stoves, and we've got a model of camp stove, model number 1, and a second model, model number 2. And we want to see which one, if there's a difference between them regarding how much time it's required to bring water to a boil. So notice that's our variable of interest. And it says that it's normally distributed. And they want us to tell if there's a difference either way between the performances. So is there any difference either way? And they want us to use a 5% level of significance. So I'm going to illustrate the critical value method, which states that we set up our hypothesis. H0 is the difference of means is equal to 0, meaning there is no difference between the stoves. And mu1 minus mu2 not equal to 0, meaning there is a difference. So this means there's no difference. And the second one means, of course, there is a difference. Okay? You could also set it up mu1 equals mu2 and mu1 not equal to mu2, depending on which textbook you're working with. Step number 2 is to find a critical value in the critical value method, and we're going to be looking for a z of alpha equal to 0.05, and it's a two-tailed test. Okay? Because of this symbol here indicates two tails. So I'm going to look up on my table. I have that wonderful little cheat table that tells me hypothesis testing critical values. For a two-tailed test, when alpha is 0.05, my critical value is plus or minus 1.96. I'm going to go ahead and draw my rejection region. So I have negative 1.96 and I have positive 1.96. I'm going to shade the tails, which create the rejection regions, which I label RR. The next step in critical value method is to calculate your test statistic, which for us is a z equals x bar 1 minus x bar 2 minus the difference of means, which is just 0, over the square root sigma squared sub 1 over n1 plus sigma squared sub 2 over n2. That's the formula from page 102. Plug in what you know. You know x bar 1 is 11.4, x bar 2 is 9.9, all over the square root of 2.5 squared over 10 plus 3.0 squared over 12. And again, watch your arithmetic. You should be getting a test statistic of about 1.28, approximately. Then you ask yourself, where does 1.28 fall in your picture? It falls in the nice clean blank area, the white area, not the shaded area. So your decision is to fail to reject H0. And of course we have a conclusion. Rather than holding my hand over the conclusion, I'll let you see the conclusion. Based on the evidence, there is no significant difference between the mean boiling times of the two stoves at alpha equals 0.05. So this is our answer. But all the steps 1 through 4 are what we had to do to get to that answer. Okay? And in the next video, I'll show you the same example, but with the p-value method using the calculator instead.